Hi guys, this is Miss Gold. Today's lesson is Module 3, Lesson 12, the area and circumference of a circle. Your outcomes for today's lesson are students give an informational derivation of the relationship between the circumference and the area of a circle. Students know the formula for the area of a circle and use it to solve problems. Students examine the meaning of quarter circle and semicircle. And finally, students solve area and perimeter problems for regions made out of rectangles, quarter circles, semicircles, and circles, including solving for an unknown length when the area of the perimeter is given. The first thing I want you to consider is the circle. And we want to find or create the formula for area of a circle. So I want you to picture a circle here, and we have cut it into 16 pieces. And if I wanted to, I could cut it down into many, many more equal-sized pieces. And if we take those pieces, break them apart, arrange the triangular wedges by alternating the triangle directions and sliding them together to make a parallelogram. Cut the triangle on the left side in half on the given line and slide the other half of the triangle to the other end of the parallelogram in order to create an approximate rectangle. So you can see here we're cutting apart the pieces and moving them together, doing the opposite sides here and pushing them into this area here. Once we do that, we get a figure that's like this. And you can see there's still a little bit of a curve on each of these, but if I were to take all of my pieces and cut them down further, you'd find that eventually that would flatten out and become a straight line. And so you can see when we cut up the pieces of the circle and arrange them like this, they really form the shape of a rectangle. So here, if you'll notice, this is really the radius of the circle. So it comes from this piece right here. And then for this, you can see that this is made up of all of the edges of the white parts of the circle. So here, if we follow that around, you can see really what we're talking about in terms of length is the circumference of half of the circle, and that's where we get this from. So here, we can multiply these two to come up with our area. So we know that the circumference of a circle, and you can always find this on your reference sheet, is 2 pi r. But if I'm talking about half the circle, we divide this by 2, so the 2's cancel out, and so we're left with just pi r, and so this is where we get the length of our rectangle that we formed. And as we said before, the width is the length of the radius of the circle. So if we find the area of a rectangle, also you can find this on your reference sheet, is length times width. It's also known as base times height. It depends on how you like to look at it. So here we have length is pi r times the width, which is r. And we know that r times r can be simplified by writing as r squared. So this is where we get the formula pi r squared. And this formula for area of a circle can also be found on your reference sheet, but I wanted to give you an idea of where this formula actually comes from. So let's take a look at example 1. A sprinkler rotates in a circular pattern and sprays water over a distance of 12 feet. What is the area of the circular region covered by the sprinkler? So when I'm thinking about area, we need to figure out what shape we're actually dealing with. So if you picture a sprinkler head rotating, it's going, as it says, in a circular pattern. So here we can draw a circle, and the sprinkler head would be located right in the center here. And so when it rotates around, it sprays water, and it says it was a distance of 12 feet. So we've drawn a diagram to help assist us in solving our problem. And in this problem, the distance of 12 feet, we can clearly see represents the radius. So the radius is equal to 12 feet. So what information is needed to solve this problem? Let's think about all the different elements we need. We need to know the fact that the sprinkler is forming a circle. Then if we want to know the area, we would need to know the area formula for a circle. So notice here I'm using a capital A to represent area, and then I use a subscript of a C to show that I'm finding the area of a circle. And you don't have to do the subscript. I like to do it because it helps to keep me organized and knowing which formula I should be using. So we know from our previous work that the formula is pi r squared, but again, you can always pull that off of your reference sheet if you don't remember. And then since we're using the formula pi r squared, we definitely would need to know the radius. And as you can see from drawing the diagram and identifying the radius, we have all of those elements. So let's go ahead and solve this problem. So I'm starting off with my formula. I always like to write my formula first and then I'll substitute. It helps me to make sure I don't make a mistake. So pi times the radius, which we found to be 12. Now anytime I'm substituting, I'm going to substitute in parentheses. So the 12 goes in for r, and then that is raised to the second power. If I do 12 squared, now notice I have to do 12 squared first because order of operations, exponents comes before multiplication. I get 144 pi. Now, if this problem asked me to express this in terms of pi, my answer would actually be done with the exception of adding on feet. However, they said at the top, express your answer to the nearest square foot. So that tells me that I actually need to multiply pi into my answer. So we're going to do 144 times pi, and it's important to know that they did not tell us to use just 3.14. A lot of times they will be very specific about how they want you to use this. Sometimes they'll say in terms of pi. That's the case where we would leave pi out. Sometimes they'll say to use 3.14 for the value of pi. Here they didn't mention it, so I'm going to assume that we are using exactly pi and we're going to multiply it in. So when I do it on my calculator, I'm going to make sure that I use the pi button and not just 3.14 because it could make a difference, especially since we are rounding our answer. So let's go ahead and do that. We get 144 times pi is equal to 452.389, and then it goes on from there. Now after the 9 is a 3, so I did not round the 9 up, I kept it the same. But when we look at our final answer here, it says round your answer to the nearest square foot. So when they're asking for a whole number, they're asking you to round the ones place. So the ones place is here, and I always look to the number before it. The 3 tells the 2 to stay. So my approximate answer, and notice I'm not using equals anymore, and actually we shouldn't use equals here either, because this is also an approximation. And so our approximated answer is 452 square feet. The two parts to example 2 are two different problems that you could come across where they don't ask you for the area of a whole circle, but parts of a circle. And so if I was looking for the area of a semicircle you can see here is half a circle. So to find the area of this, I would simply take my area and divide it by 2. And so when I plug in my formula here, we have pi r squared would simply be divided by 2 after we calculate. So here, let's plug in our radius. So be careful here, they are not giving us the radius. They actually give you the length of the diameter, which is all the way across here. So my radius is not 14, but half of 14, which is 7. So when I plug in here, we're going to substitute the r with a 7. Again, you have to follow order of operations, so you should not be dividing before you raise to a power. Here I will get pi times 7 squared, which is 49, divide by 2. And then I can go ahead and divide by 2. 49 divided by 2 gives me 24.5 pi. And they didn't mention anything about how they would like me to present the answer. So I'm actually going to leave this as exact as possible. I'm going to leave it in terms of pi because this is an exact answer. Anytime we have to multiply pi into it, we're really giving an approximate answer or a rounded answer. So I'd like to get it as exact as possible. So let's leave it in terms of pi. So let's write that down here as a note. This is in terms of pi. And then we just need to add our units. So this is centimeters and it's area, so it's squared. A quarter circle is exactly what it says it is. It's a fourth of a circle. So to find the area of a quarter circle, we take the area of the whole circle and divide by 4. Think about the fact that there are 4 quarters in a dollar. So I'm going to take my area formula, pi r squared, and divide by 4. Let's substitute. This time we are given the r value of 6, so we're just going to substitute 6 in parentheses. Six squared gives me 36. And then 36 divided by 4 is 9. Again, I'm going to leave my answer exact in terms of pi, so this is centimeters squared. So just a note here again, in terms of pi is giving you an exact answer, not rounded or approximate. Finally, let's look at example 3. The circumference of a circle is 24 pi centimeters. What is the exact area of the circle? Draw a diagram to assist you in solving the problem. So let's start by drawing a circle. And in our circle, we would need to know the radius, but you'll notice in this, we were told the circumference is 24 pi. That tells us, it's basically the perimeter of the circle, so it tells us the distance around it. And since we don't know the radius, we're going to have to call this r. So let's think about what information is needed to know. Let's think about what information is needed to solve this problem. We're definitely going to need to know the circumference formula, and you can get this off of your reference sheet. It's 2 pi r. We are also going to need to know the area formula, which is pi r squared. And so basically what we're going to do is work backwards from the circumference to find the radius. So the circumference, we will solve to find the radius, and once we know the radius, we can find the area. So this is kind of our plan of attack for this. So let's start with our circumference formula. C equals 2 pi r. The only thing I can fill in here is C. C is 24 pi. If I wanted to solve for r, I'd have to get rid of the 2 in the pi, and you'll notice that these are all being multiplied, 2 times pi times r. So we would do the opposite operation here, division, and I'm going to divide by the 2 things I want to get rid of, 2 pi. And if I do it to one side, I have to do it to the other side. So when I do that, the 2 pi's over here are going to cancel, leaving us with r. And over here, the pi's cancel, because we have pi on top and pi on the bottom. And then 24 divided by 2 leaves us with 12. So this tells me the radius of my circle is 12. Now that I know that, I can calculate the area. So area is equal to pi r squared. And we're going to substitute r with what we just found r to be, 12. 12 squared is 144 pi. Now notice, they didn't say in terms of pi for the answer, but they said, what's the exact area of the circle? The exact area of the circle is always in terms of pi. So my final answer here is going to be 144 pi centimeters squared. Some relevant vocabulary that you might want to be aware of is a circular region or disk. Given a point C in the plane and a number where the r is greater than 0, the circular region or disk with center C and radius r is the set of all points in the plane whose distance from the point C is less than or equal to r. The boundary of a disk is a circle, and the area of a circle refers to the area of the disk defined by the circle. So essentially what they're saying is they're referring to our example, number 1, that had to do with a sprinkler rotating in a circular pattern. It creates a circular region, and so that's what helps us to determine that it's going to be the shape of a circle, and then we're finding the area of a circle.